So there are 4 different ways to find the intersecting point. First is graphical method, second is substitution method, third is elimination method, and fourth is cross multiplication method. We are going to learn step by step each method in detail. So we are starting with the first method, which is graphical method. So for graphical method, you need to find the coordinates for each of the equations. We have already done that in the previous session. So I am going to represent both equations on graph, then we are going to find which is the intersecting point. Okay, so let's start with this equation. First I am going to represent 0 and 1. Y is equal to 0 and x is equal to 1. Y is equal to 0 will give me point on x-axis, which is over here. Let's talk about the second point. Y is equal to 1 and x is equal to 3. So y is equal to 1 and x is equal to 3, which will be over here. So if I will connect both points, I will get a straight line. So if we represent the first line on a graph, it will look something like this. I have represented each point on a graph. Y is equal to 0, x is equal to 1 over here, which will come on x-axis. The second point is y is equal to 1 and x is equal to 3. So if I represent that on a graph paper, this point will come over here. And if I connect it, that will give me the straight line. Let me do the same for the another equation. Y is equal to 0, x is equal to 1. Again the same point will lie on x-axis. So this is the point again which is coming over here. And let's do for the another coordinate, which is y is equal to 1 and x is equal to 2. So y is equal to 1 over here and I will go till 2. So if I connect those points, I will get another straight line. Let me just name it for our convenience. This line is for x minus y is equal to 1 and another line is x minus 2y is equal to 1, right? So we can see that we are able to observe these both two lines are intersecting on a one common point. That is our point of interest. That is the point, we call it as an intersecting point. This is the way to find the solution of both equations with the help of graph. We are representing on the graph and then we conclude that they do have one common point. So let me just write that common point here as well. Okay, x is equal to 1 and y is equal to 0. So I can conclude that 0 and 1 is solution of this two equation. Right, we are going to find the solution for two different equations. So let's find solution for another two equations, which is x plus y is equal to 2 and x plus y is equal to 3. So here again I am going to take two values, which is y is equal to 0 and 1. Then I will find the value of x. Same I will do over here. Y is equal to 0 and 1. And I will find the value of x. So let's substitute. First I will substitute y is equal to 0. So I will get x plus 0 is equal to 2 and x is equal to 2 is my answer. Let's substitute another value of y, which is y is equal to 1. So x plus 1 is equal to 2. And if you shift over here, that will become minus 1, 2 minus 1, that will give you x is equal to 1. So that's the another point. Let's do same procedure for this equation. I'll substitute y is equal to 0. So x plus 0 will give me 3. So x is equal to 3. Let's substitute over here. And y is equal to 1. So x plus 1 over 3. The same one will move over here and that will become negative 1, and 3 minus 1, that will give me x is equal to 2. So I am going to plot the same coordinates on the graph and I am going to find what is the intersecting point between them. So first is y is equal to 0 and x is equal to 2. So evidently as y is 0, the point is going to lie on x-axis. So y is equal to 0 and x is equal to 2 is this point. Let me do another one. X is equal to 1 and y is equal to 1. So this will be around here. Let me connect the dots. So this is the equation for the x plus y is equal to 2. Let me plot the coordinates for another one. Y is equal to 0, x is equal to 3. X is equal to 3 will be over here, and y is equal to 1 and x is equal to 2. Y is equal to 1 and x is equal to 2. So if you see, this is a very surprising thing over here. They are not having any kind of common point between them. So we can conclude that they are parallel lines. Before this session, we learned that there are three different cases when we consider two equations, either intersecting, then parallel or coincident line. So this is the second case. These lines are not having any kind of common point between them. They are not having any intersecting point. So we cannot find solutions in this case. So this case is considered as there are no solution of parallel lines. They do not intersect. We are already aware of that parallel lines do not intersect. So there is no solution for this case. Let's move on for the another case. Let's talk about the third case. We are taking two pair of equations as x plus y is equal to 1 and 2x plus 2y is equal to 2. Again, I am going to choose two different values of y and I will get the answer of x in each case. So the values are 0 and 1, same over here 0 and 1. So let's substitute y is equal to 0. So x plus 0 is equal to 1. So x will be 1. Let's talk about the second case. Y is equal to 1. X plus 1 is equal to 1. Now if I shift this 1 over here, that will become negative 1 and 1 minus 1 will give me 0. So x is equal to 0. Let's talk about this case. So y is equal to 0. That will give me 2 into x plus 2 into 0 is equal to 2. So I have equation as 2x is equal to 2 and this 2 will go into denominator and I will get x is equal to 2 over 2 is equal to 1. So I can write here as 1. Let's talk about y is equal to 1. So 2 into x plus 2 into 1 is equal to 2. So 2x plus 2 is equal to 0. Now is equal to 2. If this 2, if I shift over here, that will become negative 2. So 2 minus 2, it will make 0. So we are having equation as 2x is equal to 0. This 2 will go into denominator. So 0 over 2. Now when we have 0 in numerator, answer will always be 0. So my answer is 0. So if you see over the coordinates, I have similar coordinates in both of the cases. 0 and 1, 1 and 0, 0 and 1 and 1 and 0. Let's see what interesting result do we get when we plot on a graph. So first I will start y is equal to 0. So point will be on the x-axis, which is over here. Second point, y is equal to 1 and x is equal to 0. The same point is on y-axis. And let me draw the line. So this is the line. Let me just give a name as well, same as it is. X plus y is equal to 1. Let me plot the another one. Y is equal to 0, x is equal to 1. So again I am having the same point. Same goes for the second case. Y is equal to 1, x is equal to 0. Again same point. So how are we going to represent? What we will do, we will extend this line to represent that there is also another line present over there, and we will give the name as well. 2x plus 2y is equal to 2. So you can see that one line is lying over the another. This is the case of coincident lines. You can even see from the equation, there is one very beautiful observation. If you made it, then I appreciate your efforts. You can see over here, from all terms I can take 2 as a common, right? So if I divide all of them with 2, let me put 2 over here, 2 over here, and 2 over here. So as a result of it, what will I get? 2 will get cancelled, x plus, as it is, there is no negative, 2 get cancelled again in this case, so that is y only, 2 get cancelled is equal to 1. So if you see over here, this equation and this equation over here, both are equal. So whenever we talk about coincident line, remember they are having different faces, but their character is same. They are going to represent the same line with the help of different coefficients. If you multiply 3 over here, you will get the third equation, but the line is going to remain same. Here we are having infinitely many solutions. You can have as many solutions if you substitute 3 in this case. Let me just take one more number. If you substitute 3 over here, and let's get the value of x over here. So y is equal to 3, and let's get value of x, which is x plus 3 is equal to 1. If I shift this plus 3 over here, that will become minus 3, and 1 minus 3, that will give me x is equal to minus 2, right? And if I substitute the same 3 over here, I will still get the value of x as a minus 2, because both lines are equal. So this was our graphical method. We discussed 3 cases. First was about intersecting line, second was about parallel line, and third about coincident lines.